Section 2.1a, starting a new unit. Increasing, decreasing, and constant functions is what we're going to start out with. Then we're going to introduce the idea of a relative maxima or minima, and then we'll kind of put it all together to wrap up the section. So first of all, we have to talk about what it means for a function to be increasing, decreasing, or constant. Okay, so we have some examples here. And this is kind of our official math definition, that an increasing function is a function on an open interval I. Now this is important. Open interval. Open interval means that we're not including endpoints. So if we say the interval is from like 1 to 10, then that would be 1 with a parenthesis over to 10 with a parenthesis. Not technically at 1, not technically at 10, but infinitely close to 1 and 10 and everything in between. Okay, so a function is said to be increasing on an open interval I for all a and b in that interval if a is less than b implies that f of a is less than f of b. So let me give you a little picture to help you put this together. So let's say that a is here and let's say that b is here, right? Then we want to find, let's say our function looks, I don't know, something like this, right? So this would be our y value for a. So this would be our f of a. And this would be our y value for b. So we'll call this f of b. So what this is saying is that it's considered to be an increasing function if as my x's get bigger, meaning all my a's that are less than b, right, as they increase, then my y values are increasing also. Or in other words, if I pick any x's in here, f of b and f of b should be the highest point, right? And then as we get smaller, the y's get smaller. As we get bigger, the y's get bigger, okay? So we always read our graph from left to right. So basically what we're saying is as x's get bigger, our y's also get bigger, okay? Now, we look at our y values to determine what's happening, okay? So if I were to just trace my finger, just put my finger on there and trace this function, my finger's going up. So that tells me this is an increasing function. But when I ask for the interval where it's increasing, I'm actually asking for what x values is the y values increasing. So that would be this interval from a to b. And the way that we write that is with open interval. So parentheses from a over to b would be the interval where this function is increasing, right? Same thing with decreasing. Let's say here's our a and here's our b. If a function is decreasing, let's say it looks something like this, then notice my very first endpoint, my y value of a here, is going to be the higher point, right? And then if it's decreasing, it's going to fall down to the end of that interval, which is b. So this would be my f of b point. Or you can think about it as I trace it with my pen or my finger from left to right, as my x's are getting bigger, notice my y's are starting to fall, or they're getting smaller, okay? As x's get bigger, my y's get smaller, okay? So again, we're asking for the interval, the open interval, meaning we're not including endpoints, where all of my x's, as they're increasing, their y values are decreasing. So that would be all the x's between a and b. So notice we're always writing our interval in terms of our x values, okay? I'm going to put up here. These are our x values whenever we're talking about increasing, decreasing, and constant. Okay, so we've done increasing, we've done decreasing. The last one we have is constant. So this would look something like if here's a and here's b, right? If it's remaining constant, then that means our y value is not changing. So that would be something like this, right? Something like that, where both of our y values are equal. So f of a equals f of b. And that's true for all x's between a and b, right? So this function would be constant over the interval a, b, okay? Or in other words, as our x's get bigger, our y's stay the same, okay? All right, so that's kind of what it looks like. Now we want to be able to look at a picture and determine which open intervals represent increasing intervals, decreasing intervals, or constant intervals. Okay, so let's look at some examples on the next page. Whoops, wrong page. All right, so looking at this graph, I need to trace with my finger. So notice if I start at this arrow up here and I start tracing, my finger is going to fall, right? So that means I'm starting off with a decreasing interval. Now I'm only starting off with a decreasing interval until I get to this point right here, right? So I'm going to use a highlighter and I'm just going to draw a line all the way through so that I can see the x value. Remember, because we do this in terms of our x's. So the x value where this changes is this value right here, which is what? Negative 1, 2, 3, 4, right? So I'm just going to put a note here that up until this x value of negative 4, right, my line is decreasing. So I'm going to put a little d up here for decreasing, okay? Then at negative 4, notice it changes and it starts going up. So as it goes up, that means now it's increasing, right? And it's increasing until we get to this point, or this little open dot. So again, I'm just going to draw with my highlighter a line right there so that it's easy for me to see from this x value to this x value, right? So this x value is negative 3. And then notice from negative 3 over to this point, right? Now we have a constant interval. So this is a constant interval, and again, I'm going to go ahead and highlight where that interval is going to end, which is right here. Okay. And then when I look, I start getting this like parabola type shape, right? So from that dot, notice it starts to dip until it gets down to this bottom point, and then it starts to rise again. So that means right down the middle of this little parabola is another point where it changes. Okay, so from this point down to the base of that dip, this is going to be decreasing. So this is another decreasing interval. And then it changes from the base of that dip all the way up until we get up to the peak of this little mountain here, the peak of this curve. So I'm going to go ahead and again, just so I can identify my x values. Oops, and I forgot to put them over here. So this x value was 0, this x value is 1, and now we're talking about this x value, which is 5, right? So from 1 to 5, this is an increasing interval. So I'm just going to put an I there, increasing. And then the other side, right, we start going down the hill, so this is going to be a decreasing interval over to that open dot. And that open dot is located at x equals what? 5, 6, 7, 8. So it's going to decrease over to 8. And then this last little piece is going to be increasing, right? And there's a stopping point because I'm ending with a solid dot. So I'm going to go ahead and just draw the last little bit there. So this is at what? 10, 11, 12. And that last little bit is increasing. Okay, notice I highlighted the dot over here as my ending point. On this slide I didn't because there was an arrow. So this is going to keep going and going and going and going and going. Okay, so now that I can easily see my intervals here, now all I have to do is write them in interval notation. So I have decreasing, increasing, and constant. Okay, so my decreasing interval, this first interval, this line, remember we write it in terms of our x's. So this direction is our negative infinity, this direction is our positive infinity. So this first piece is going to go all the way back to negative infinity, and remember that interval ends at this x value, which is at negative 4. So from negative infinity over to negative 4, that piece is going to decrease. So negative infinity to 4. And we always write it with open parentheses because these are open intervals. We're not including the endpoints. Some textbooks will, but we're not. Okay. All right. Our next interval was increasing, and we were increasing between negative 4 and 3. So increasing between negative 4 and 3. Then we have a constant interval from -3 to 0. So -3 to 0. And then we had another decreasing interval from 0 to 1. So 0 to 1. And then we had another increasing interval from 1 to 5. 1 to 5. And then we had another decreasing interval from 5 over to 8. 5 to 8. And then we had another increasing interval from 8 to 12. 8, 12. Okay, and one thing that I do want to point out is notice I'm not using union symbols in between these intervals. That's because I'm saying it's decreasing on this interval and this interval and this interval, okay? Increasing on this interval and this interval and this, meaning it's true for all of these. When you use a union symbol in between your intervals, it means it could be this interval or it could be this one, right? And this is not an either or. This is, it is decreasing for all of these. It is increasing for all of these. It is constant for all of these. So we just use a parenthesis to show it's true for all. Okay, so this would be my solution, listing the intervals where it's increasing, decreasing, and constant. Okay, so there is 2 graphs below for you to try. I want you to go ahead and pause the video and give those a try, and then when you're ready to go over them, unpause and we'll see how you did. Okay, let's go ahead and see how you did. On number 1, our points that we're going to highlight are x values where it changes from increasing to decreasing to constant. So notice if I start tracing this one, it's going to be decreasing until I get to the origin here, right, which is an x value of 0. And then from 0 over to this point, it's increasing, and that x value is 1, right? Then it's going to be constant across this little piece. That little piece is from 1 to 2. And then it's going to be increasing on the last piece. And the last piece starts at 2 and is going to continue on to infinity. So that means our increasing intervals are from 0 to 1 and then also 2 to infinity. Our decreasing is from -infinity up to 0. And our constant interval is just from 1 to 2. Okay. Same idea on the second one. I went ahead and highlighted where our increasing, decreasing, and constant intervals start and stop. Notice right here, I don't have any function in between there. So make sure that's not included. Okay. So, and I forgot to write my numbers down here. This is -8, and then we have -4. Then we have 1, 2, 5, and 8. Okay. So our first one is constant from -8 to 4. Okay. Then our next interval should be increasing from -4 all the way over to 1. Then we have a little gap. That's okay. Our next interval is decreasing from 2 to 5. And then our last one is increasing from 5 to 8. Again, we're talking about open intervals, okay? So this is the one time we really don't care what the little dots are doing. If they're open, if they're closed, we don't care because we're only using open intervals, meaning we're not including those endpoints, okay? All right, so now we have the general idea. Now what we want to do is look at the idea of a relative max or min. So within certain intervals, we might have one value that's higher than all the rest, or we might have one value that's lower than all the rest, right? So what we're calling a relative maximum is some value C, okay? Some value C where the Y value exists, obviously, for that C, and that C value lies in an open interval. Again, very important that we're talking about an open interval. So that means if we're talking about this interval of X values, there's some X within that interval where its Y value is either the highest point, or within that interval, there's an X value whose Y value is the lowest. Okay. If it's the highest, then we call it a maximum. If it's the lowest, we call it a minimum. Okay. Notice when you see f of c, that means this is talking about y values, okay? When we wrote our intervals for increasing, decreasing, and constant, we used x values. But when we're looking for the highest or lowest points, we're actually looking for that high y value or that high low value. We're not writing the x's, we're writing the actual high y or high low. So let's go ahead and look at this in English and see if we can kind of make some sense out of this. So I pulled this out of a different textbook. So I just want to make sure everything's defined correctly. So when we say that there is an open interval that contains this point, so like this first point is x sub 1, okay? And notice I could create an open interval around x sub 1. I could say, okay, well, how about this interval right here? That interval from whatever this x value is to this x value, it contains x sub 1. And notice if you kind of look at what that interval would contain, if I look at all these y values from here to here, notice x sub 1's y value is the highest point, right? And I don't even actually have y values over here, but I'm just going to say if this is x sub 1, then this would be the y value for that. So let's call this f of x sub 1, okay? So whatever its y value is, notice it's higher than all these y values and all these y values that all came from this open interval. So that's what defines it as a relative maximum, okay? Same thing with like x sub 2, right? I could find an open interval around x sub 2, and if I kind of look at what y values are included there, notice x sub 2 is the lowest y value of all the other y values associated with that interval, right? So this point right here would be the y value of x sub 2. So we're just going to call this, here, I don't have much room in here, so I'm just going to do this. Let's call this f of x sub 2, that point. Okay, and it's lower than all the other y values. So I'm able to find an open interval that's defined for this function where that y value is the lowest, okay? Let's look at x sub 3. Same thing here, right? I could find an interval that contains this point to where this is the highest y value, right? Same thing. So that high y value would be f evaluated at this x, which is x sub 3. And it's going to be a maximum because it's the high y value within that interval. Okay, so far I kind of agree with this little textbook excerpt that I took. The only problem I have is this last one. This last one, I agree that x sub 4 is lower than some of these y values, but remember, we're defining this on an open interval, and I cannot create an open interval that includes x sub 4 because open intervals do not include endpoints. And right now, x sub 4 is the endpoint of this function, right? And if I have to do things with an open interval, then that means I can't include x sub 4. And that is how our textbook defines it, is that whatever c value, or in this case, x sub 4 value that we're talking about, it has to be included in that open interval. Now, if this line went just a little bit further and we had some more x values on this side, then I could include it. But here, since it's the endpoint and endpoints are not included, I can't create an open interval that includes that endpoint, then it is not a relative maximum, okay? So this one is no, okay? Because x sub 4 cannot be included in an open interval, okay? All right, so now that we know what our relative max and mins are, we just list their y values. So that means our relative maximums for this one would just be this point up here and this point here. Now that point is not x1 and x2, right? Its x value is x sub 1, but this actual point up here, this high point, is my y value. So that would be f of x sub 1, and this high point y value, which is f of x sub 3, okay? And my relative minimums, or my low y values, I only have one, which was right here at x sub 2. And notice its y value is f of x sub 2. Okay, so those are my three relative minima, right? Relative maxima and minima. So there's a practice problem that I want y'all to try. So determine which of these is a maximum, which of these is a minimum, and for yours is labeled a little bit differently than mine. So A, B, C, D, E, F, G, those are all the Y values. Okay, so when you actually list your minimum and maximum, just use the letters. Okay, so I'll give you just a minute and then we'll go over it. All right, let's see how you did. First of all, our points that we're defining to be relative maximum or minimum have to be able to be contained within an open interval defined for the function, which means endpoints cannot be included in an open interval, right? Because their x has to be defined for that point and it has to be the highest or lowest, right? Within an open interval. So for this one, I can't include A, right? Because it is not included in an open interval. And I cannot include G because it's an endpoint. It cannot be included in an open interval. Okay, so then I just look for my high and my low points. So my high points that are included within the function, right, would be B and E, and my low points are D and F. Notice, even though they define this point C, it is not a maximum or a minimum, because if I create an open interval around it, it is not the highest or lowest Y value for a grouping of X's. Okay, does that make sense? All right, so now we're going to put the two things together. We're going to look at increasing, decreasing, and constant, and then we're also going to identify our relative max and min, except instead of me just giving you the picture, we're going to have to come up with the picture first by graphing the function, and then we'll identify where the increasing, decreasing, and constant intervals are, and our relative maxima and minima, if there are any that exist. Okay, so let's look at this first one. We have f of x equals 4 minus x squared. So anytime we want to graph this, a good idea is in your brain to think about what type of shape this function is going to make, right? In this case, I see the x squared. Anytime I see an x squared, I'm thinking parabola. So maybe this is a parabola opening up, maybe this is a parabola opening down, right? But I want to make sure that I'm going to get a parabola shape. I don't want to end up with just like half a parabola, right? So to do that, I look at whatever it is that's being squared. Sometimes it's just x being squared. Sometimes it's a quantity being squared. In this case, it's just x. Only the x has the squared on it. So I want to look at what's being squared and decide what makes this 0. Because if I can determine what would make the squared thing 0, that gives me the center of the parabola. That's the center. Okay, so here the only thing being squared is my x. So what would make x 0? Well, 0, right? So I'm going to just use a table of values to come up with a good picture. And I want to make sure that 0's in the center, because I want to make sure that I get not just one side of the parabola, right? I want the whole parabola, both sides, so I get a parabola shape. So 0 is going to be the center, so I want to pick a couple numbers on this side and a couple numbers on this side. So I'm just going to do -1 and -2, +1 and +2. And now I just plug them into my function to see what their y values are. So when I plug in -2, I'm going to get 4 minus -2 squared. Order of operation tells me to square the -2 first. So that gives me 4 minus a +4, which is then just 0. Okay. Then I want to do the same thing for -1. Plug it into the function. 4 minus a -1 squared. Again, we square first, so that gives us 4 minus a +1, and 4 minus 1 is 3. Then I plug in my 0. 4 minus 0 squared is just 4 minus 0, right, which is just 4. And then I do the same thing with the other points. When I plug in 1, 4 minus 1 squared is 4 minus 1, which gives me a 3. And when I plug in +2, 4 minus a +2 squared gives me 4 minus 4, which is then just 0. Okay, so now I have a pretty good idea of what this parabola looks like. So I'm going to go ahead and plot all these ordered pairs. So at -2, I'm at 0. -1, I'm up at 3. 0, I'm at 4. 1, I'm back down at 3. And 2, I'm back down at 0. So I go ahead and connect my dots, draw arrows so I get a good parabola shape. And now I want to determine where my function is increasing, decreasing, and constant. So if I start tracing this with my finger, we can see my finger is going to go up, right, until I get to the top of this parabola. So that means this side is going to be increasing up until I get to the y-axis, right? So I'm going to go ahead and just highlight down so that I can write that x value, because increasing, decreasing, and constant is based on the x value. So the x value here is 0. Okay, so we're going to be increasing up to x equals 0, and then after that, then we're going to be decreasing. Okay. So that means that my increasing interval is from -infinity to 0, never including it, right? Because we do increasing, decreasing, and constant on open intervals. And then it's going to be decreasing from 0 on out to infinity, okay? Remember, these two are done with the x, right? And then we do have a relative maximum, because this point right here is our highest y point, and it is included within an open interval, right? So I'm going to go ahead and say that we have a relative maximum at the y value that is the highest, which in this case is up at 4. Okay, so these would be my solutions here. Okay. All right, let's look at another one. Same idea. This one's not an x squared, so it's not going to make a parabola. It's going to make a v. Okay, absolute values always make a v, either a v pointing up or a v pointing down. So similar to a parabola, but not quite. Okay. All right, so in order to determine where the point is of that v, that low point or that high point, we do the same idea, is we look and see what would make inside that absolute value 0. Just like we look to see what would make inside the squared quantity or the squared item 0, here we're going to look and see what makes this 0. Because whatever value makes that 0, that's going to be the point or the center. That's the center of our v. Okay, so in this case, what would make inside here 0? Well, it would have to be x being -3, because the -3 plus 3 would create a 0, right? So when I make my table of values here, excuse me, I'm going to make sure I choose -3, and then I'm just going to pick a couple of numbers smaller and a couple of numbers bigger than -3. So let's do -4 and -5. And then -2 and -1. Now we're just going to plug them into the function. Remember, absolute value is telling us the distance a number is from 0. So if you plug in a positive, you're going to get out a positive. You plug in a negative, you're going to get out a negative. I mean a positive, right? Because distance is always positive. So if we plug in -5, we'll get the absolute value of -5 plus 3 minus 5. -5 plus 3 is -2, but because it's inside absolute values, it comes out positive. So we get 2 minus 5, which is -3. Okay. I want to do the same thing with -4. Have the absolute value of 5. J's Louise. The absolute value of -4 plus 3 minus 5. -4 plus 3 leaves me with a -1. But that -1 comes out of the absolute value positive. So I have a +1 minus 5, which gives me -4. Then I'm going to do the same thing with -3. Absolute value of -3 plus 3 minus 5. 3 plus 3 is 0, and the absolute value of 0 is just 0. So this ends up just equaling -5, right? And then we plug in a -2. I get the absolute value of -2 plus 3, which is a +1, right? +1 still comes out positive. So I get 1 minus 5, which is -4. And then my last value I'm plugging in is a -1 plus 3 minus 5. -1 plus 3 is a +2. +2 comes out of the absolute value as a +2. And 2 minus 5 gives me a -3. So now we're going to go ahead and plot all these points and make sure that we get a nice V shape. Okay, so at -5, we're down at -3. -4, we are at -4. -3, we're at -5. -2, we're back up at -4. And -1, we're back up at -3. So when I connect my dots, I should have a nice V shape. Okay. So notice, in order to find our intervals of increasing, decreasing, and constant, I now am going to trace my finger down, which means that that is a decreasing interval until I get to that center point of the V, right? I'm going to just highlight the center point of that V so I can write what its x value is. And its x value happens to be -3. So that means from -infinity, as far as I can trace my finger down to that point, it's going to be a decreasing interval, and then it changes at -3 to become an increasing interval. Okay, so decreasing from -infinity to -3, always with a parenthesis for decreasing, increasing, and constant. And then it's going to change to increasing from -3 to infinity. Okay, and then here I do have a low point that is included. So that means that I have a relative minimum, which is at what y value? Okay, its x value is -3, but when we want to identify that low point, we look at its y value, which in this case is -5. Okay. All right, so on the next page, there are 2 for you to try. So go ahead and pause the video, give that a try, give it a whirl, and then we'll go over it. All right, let's see how you did. So on the first one, we want to make sure whatever's being squared, what would cause the squared thing to be 0? In this case, only the x is being squared. What would cause x to be 0 is just if we plug in a 0. So we picked a couple points on either side of 0. When you plug them in, you should get a parabola that goes just nicely through the origin, right? Which is decreasing from -infinity up to 0, and then increasing from 0 to infinity. Okay, our low point here, our relative minimum, is at y equals 0. Let's look at our second one. Second one, same thing, we have an absolute value. What will make inside the absolute value 0 so that we can find our center? In this case, that would just be 0. So we plug in 0. We also plug in a couple of points on either side of 0. Once you get all your ordered pairs, we plot it, and we should get a V that's opening downward. Okay, so notice it's going to be increasing on this side, and then it changes at x equals 0 to be decreasing. So increasing from -infinity to 0, decreasing from 0 to infinity, and then only our relative maximum has a y value, right? These are always determined off of x's. Our maximum is our highest y, which in this case is 1. Okay? All right, that is the end of section 2.1a. So you should now be able to complete both the My Math Lab assignment and the worksheet that go with that section. All right, let me know if you have any questions.